Example 1.3. Draw the ray diagram using pencil and determine the characteristics of image form based on the object's distance below. In the table here, we have the object distance u, ray diagram, and also image properties or characteristics of image. Let's look at the first case. If u is greater than r, this shows that object distance is greater than the radius of the curvature. So we can show that object is situated at this position. Why? Because r is here. This is r and this is u. So object must be situated at this point, which is greater than r. Step 1. The incident ray is parallel to the principal axis and the reflected ray will pass through point F. Step 2. The incident ray will pass through point F and the reflected ray will parallel to the principal axis. Step 3. This is optional. The incident ray will pass through point C and the reflected ray will also pass through point C at opposite direction. Here we can see the intersection point between the reflected rays, so image will form here. The characteristics of the image form are real. Why real? Because if the image form in front of the mirror, it will be real image, but if the image form behind the mirror, it will be virtual image. So the differences between real image and virtual image is the position of the image form. Second characteristics is inverted, diminished. So you can compare the image with the object size, so it's smaller. And the last one, the image form between point C and point F, or you can also say that the image form in front of the mirror. Second case, when the object distance is equal to the radius of curvature, this shows that the object will be situated on or at point C, because this is the object distance u from point C to point P. At the same time, r is also the distance between point C and point P. So object will be on point C. The first step, incident ray will be parallel to the principal axis and the reflected ray will pass through point F. Second step, incident ray will pass through point F and the reflected ray will parallel to the principal axis. We cannot do step 3 because the incident ray cannot pass through point C as the object is on it. Here we can see the intersection point between the reflected rays. So image will form here. The characteristics of the image are real, inverted, same size, form at point C or in front of the mirror. When the object distance is in between focal length and radius. Focal length is the distance between point F and point P. Radius is the distance between point C and point P. So the object will be at in between point C and point F. Step 1. The incident ray is parallel to the principal axis and reflected back passes through point F. Second step. The incident ray passes through point F and the reflected ray parallel to the principal axis. Here is the intersection of the reflected rays, so image will form here. The characteristics of the image are real, inverted, magnified, and formed at a distance greater than r or in front of the mirror. Next, when the object distance is equal to the focal length. Focal length is the distance between F and P. So object is situated at point F. Step 1. Incident ray is parallel to the principal axis and the reflected ray will pass through point F. We cannot do step 2 because incident ray cannot pass through point F. So proceed to step 3. Incident ray will pass through point C and the reflected ray also will pass through point C at opposite direction. Here we can see that these two reflected rays are parallel to each other. So the image formed will be highly enlarged or highly magnified, sangat-sangat besar, because we cannot see where is the intersection point of the reflected ray, and the image will be formed at infinity because the intersection is very far away. The last case for the concave mirror is object distance is less than the focal length. So focal length is the distance between F and P. So object distance is less than it, so it will be here at any point as long as it less than F. So for the first step, the incident ray will parallel to the principal axis and reflected ray passes through point F. There is virtual ray right here because the object distance is very near to the mirror. Next step is the incident ray will passes through point C and the reflected ray also will passes through point C at opposite direction. So the reflected ray is actually will be formed at back of the mirror and the image will be at this point. From this ray diagram, we can see that the image property are virtual because the image formed at the back of the mirror, upright, magnified, and formed at the back of the mirror. Please remember that for mirrors, real image means that the image formed in front of the mirror, while virtual image is the image formed behind the mirror. For example 1.4, draw the ray diagram using pencil and determine the characteristics of image formed at any object distance in front of the convex mirror. Why does concave mirror have few cases, while for convex mirror there's only one cases at any distance in front of the convex mirror? It is because concave mirror, it has point C and point F in front of it, while for convex mirror there is no point in front of the mirror because point F and point C is situated behind the mirror. So we can put the object at any distance. Okay, so how to get the image characteristics? First, step 1, the incident ray will be parallel to the principal axis and then it will diverge out. Okay, dia akan mencapai keluar daripada point F. Second step, saya skip sebab dia optional. Saya terus pergi kepada third step. So step 3 is incident ray will pass through point C and the reflected ray will also pass through point C at opposite direction. So here is the intersection point of the reflected rays and image will form here. The characteristic of the image are virtual because it formed at behind or at the back of the mirror, upright, diminished, and formed between point F and point P, vertex P right here.